So in chapter 1, we talked about rational expressions. This is a rational equation, it's called, and it's because in the equation there are rational expressions. Now, you might say, well, what's the difference between a rational expression and a fraction? In a rational expression, you have a variable in the denominator, okay? So this is the equation we have. 7 over 2x minus 5 over 3x equals 22 over 3. Well, remember, we're trying to solve for x. Now, the way that we're going to solve this is we're going to use the LCD, the least common denominator. And we're going to look at that for 2x, 3x, and 3. So you look at all the denominators and you say, well, what do I need? I need a factor of 2, I need a factor of x, and I need a factor of 3. And that'll be enough because I need a factor of 2, I need a factor of x, things that are multiplied together, right? But here I need a factor of 3 because I didn't have one yet. I don't need another factor of x. I've got one and I don't need any more. And then here, well, I've already got a factor of 3, so I'm okay. So my LCD is going to be 6x. Now, what I'm going to do with that 6x, get rid of my lines here, I'm allowed to multiply an equation by whatever I want as long as it's not 0. And so I'm going to multiply this side by the LCD, which is 6x. And then I'm going to multiply this side by 6x. And then a wonderful thing's going to happen. All right, so first we're going to distribute here. 6x times 7 over 2x. And you might be saying, well, why didn't you put 42x? I could have. And then 6x times 5 over 3x. And then on the other side, I have 22 over 3 times 6x. Yeah, you could multiply those numerators, but I didn't because here's what's going to happen. When I multiply by the LCD, because it's the LCD, all the denominators are going to cancel. So 2 goes into 6 3 times. The x's cancel, and so I'm going to get 21 there. Do you see it? 3 times 7. The 3 times the 7. Okay. Then the next term, so it's going to be minus. That's the subtraction sign right there. 3 goes into 6 twice. X's cancel, so I get 10. All my x's are canceling. Well, that's okay. On the other side, 3 goes into 6 2 times. I'm going to get 44x. Okay, so this time I have the x there. All right, well, that's good because I wanted to solve, so let's see what happens here. 21 minus 10, what's that, 11? Now you'll notice that x is on the right-hand side this time. That just happened naturally. I'm okay with that. I don't mind it being over there. I'm going to divide both sides by 44 because I'm trying to get x by itself. I'm going to reduce that fraction on the left. And so I get 1/4 equals x. Now if we put it in set notation, we would just do it like this. Or maybe we would write x equals 1/4. Okay, and that's great. That's a lovely answer. Now you probably noticed in this video up at the top, I had some words, excluded values. Well, here's the thing. When you have a rational equation and you have rational expressions, if there's a variable in the denominator, you have to make sure that the denominator never equals 0, okay? So I cannot let 2x equal 0. I can't let 3x equal 0. And the 3, well, that's not going to be 0, so I don't have to worry about that. But, well, if I were to solve that, in other words, if you were to divide by 3 on both sides, I get x cannot be 0. And the same thing would happen if you divided by 2. So in this case, we have one excluded value, it's called. It says, hey, we're going to solve this equation, so possibilities, any real number, except, by the way, we can't have x be 0. Because if we do, then when we plug it into the equation, we get 7 divided by 0, and that's undefined. So we're not going to let you divide by 0. So you have to be careful. Now, we went through and we solved the equation, and we got an answer of 1/4. Well, that's not 0, so we're okay. So this is a lovely answer. We just have to make sure at the end that our answer is not an excluded value. Okay, you'll see some more examples.